Hello everyone, today we're going to dive into something that surrounds us every single day, yet often goes unnoticed: the weather. We look outside and see sunshine, rain, snow, or storms, but rarely do we stop to ask, why does this happen? Weather is not just about forecasts on TV, it is the complex and fascinating interaction of energy, air, and water, shaping the world we live in. At its core, weather is driven by the sun. The sun heats the earth unevenly. Land, oceans, and air all absorb and release heat differently. This uneven heating creates pressure differences, which set the air into motion. Winds form as the atmosphere constantly works to balance these differences, moving warm air toward cooler areas and circulating energy around the globe. Water vapor is another critical ingredient. As oceans, lakes, and rivers release moisture into the air, that vapor rises, cools, and condenses into clouds. Depending on temperature and conditions, this process can produce rain, snow, hail, or thunderstorms. Every raindrop that falls has traveled a journey of evaporation, cooling, and condensation, a cycle that connects every part of the Earth's surface to the sky. Storms, hurricanes, and tornadoes may look like chaotic events, but they too follow rules of physics. Hurricanes, for example, form when warm ocean water fuels rising air, spinning into a massive system because of the Earth's rotation. Tornadoes, on the other hand, come from powerful thunderstorms where wind shear twists rising air into a rotating funnel. What seems random is actually nature's raw demonstration of energy in motion. Weather also has a direct impact on us. It shapes agriculture, influences our moods, drives migration, and even determines the course of history. Battles have been won or lost because of sudden storms, and entire civilizations have thrived or collapsed depending on rainfall. Understanding weather is not just scientific curiosity. It's about survival, adaptation, and appreciation of the forces that govern our world. So, the next time you feel the breeze, watch clouds gather, or hear thunder roll, remember, you're witnessing the beautiful balance of Earth's atmosphere in action. Weather is not just what happens outside, it's the living, breathing system of our planet, shaping life itself. The sun is the ultimate engine behind every weather pattern we experience on Earth, and without its constant energy, our planet would be lifeless, still, and frozen. The warmth of the sun fuels the atmosphere, but what makes weather so fascinating is not just the heat itself. It is the uneven heating of the Earth's surface that creates motion, change, and variety. When sunlight strikes the Earth, it does not spread evenly. Areas near the equator receive sunlight directly, almost head-on, while regions closer to the poles get it at a much slanted angle, spreading the same energy across a wider surface area. This simple fact sets up temperature differences across the globe, and nature always seeks balance. Hot air rises near the equator, cooler air sinks near the poles, and in between, a global circulation of air currents begins to form. These invisible rivers of moving air are the foundation of wind, storms, and climate zones. The contrast between land and water deepens this imbalance. Land heats up and cools down quickly, while oceans and lakes absorb heat slowly and release it gradually. During the day, the land may become scorching hot under the sun, causing air above it to rise rapidly. The nearby water, still cooler, keeps the air over it dense and heavy. As the lighter, warmer air over land rises, cooler air from over the water rushes in to take its place, creating winds we feel as breezes. This same principle works on larger scales too, driving monsoons that bring seasonal rains to entire continents. Imagine billions of tons of air being pulled back and forth across the globe, all triggered by nothing more than uneven solar heating. The tilt of the Earth adds another layer of complexity. Because our planet is tilted on its axis, the angle of sunlight changes throughout the year, creating seasons. In summer, one hemisphere leans toward the sun, soaking up more direct rays, while the other tilts away, receiving weaker sunlight. This cycle explains why December is warm in Australia, while snow covers Canada. It also means that temperature differences between regions change with time, leading to shifting wind patterns, migrating storm systems, and cycles of growth and dormancy in ecosystems. The sun doesn't just give us day and night, it orchestrates an ever-changing dance of atmospheric conditions across the planet. But energy doesn't simply sit still, it moves, flows, and redistributes itself through the air. When warm air rises, it creates areas of low pressure at the surface, and surrounding cooler air rushes in to fill the gap. This is the fundamental principle of wind. The faster the pressure difference, the stronger the wind. Hurricanes, trade winds, jet streams, and even the gentle gusts that rustle leaves outside your window all trace back to this exchange. High-pressure systems where air sinks and stabilizes tend to bring clear skies, while low-pressure systems where air rises and cools are fertile grounds for cloud formation and storms. It is as though the entire atmosphere is a vast engine, constantly fueled by solar heat, redistributing energy to even things out, yet never reaching a perfect balance. Another fascinating factor is the role of the Earth's rotation, which complicates the direct movement of air. As the Earth spins, moving air is deflected, a phenomenon called the Coriolis effect. Without this effect, winds would simply blow from the equator toward the poles in a straight path, but instead they curve, creating distinct wind belts across the planet. This explains why trade winds blow steadily in tropical regions, why westerlies dominate mid-latitudes, and why polar easterlies sweep across the high latitudes. These wind patterns, all born from the sun's uneven heating, control ocean currents, storm tracks, and even the climates where civilizations rise and fall. Think of it this way: every breeze you feel on your face is the Earth's attempt to balance out the sun's unequal energy delivery. Every weather forecast is essentially a report on how our planet is moving that energy around. The sun doesn't just warm the Earth. It is the invisible hand stirring the atmosphere, driving air from one place to another, shaping the clouds, and setting the stage for every raindrop, every thunderstorm, and every calm day we experience. Weather, in its grand complexity, begins with this one truth: the sun heats the Earth unevenly, and the atmosphere is forever chasing balance. Water vapor is the hidden architect of weather, silently shaping the skies above us in ways we often take for granted. Every cloud you see, every drop of rain that falls, every snowflake that touches the ground begins with water in its invisible form. Unlike oxygen or nitrogen, water vapor is not always present in fixed amounts in the atmosphere. It constantly moves through the cycle of evaporation, condensation, and precipitation, creating the dynamic patterns we call weather. When the sun heats oceans, lakes, rivers, or even moist soil, water molecules gain enough energy to escape the surface and rise into the air as vapor. This process is invisible to our eyes, yet it transforms the atmosphere by loading it with potential energy. The air becomes not just a mixture of gases, but a container carrying fuel for clouds, storms, and rainfall. As warm, moist air rises, it begins to cool. Cooler air cannot hold as much water vapor, and so the vapor starts to condense into tiny droplets or ice crystals around dust particles, forming clouds. A cloud is not just a white puff in the sky. It is millions upon millions of microscopic water droplets suspended together, each one a product of that invisible transformation from vapor to liquid. Depending on the temperature, altitude, and wind conditions, these clouds can take different forms, from thin, wispy cirrus streaks high above to massive, cumulonimbus towers that unleash thunderstorms. What's fascinating is that this process is driven by the natural laws of physics. Air cools as it rises, vapor condenses when the air can no longer hold it, and droplets gather into something visible and powerful. The transformation from vapor to precipitation is equally remarkable. As droplets in clouds collide and merge, they grow larger and heavier. Eventually, gravity pulls them down as rain. If the air is cold enough, those droplets freeze into snowflakes, each with its own intricate crystalline design, or become pellets of hail when strong updrafts carry them through layers of freezing air. This explains why the same cloud can produce rain in one place, sleet in another, and snow in yet another, depending entirely on the temperature profile of the atmosphere below it. The water cycle is not just a scientific concept in textbooks. It is the heartbeat of weather itself, recycling the same molecules endlessly through evaporation, condensation, and precipitation. Beyond clouds and rain, water vapor plays another vital role. It is one of the most powerful greenhouse gases in the atmosphere. Unlike carbon dioxide, which traps heat over decades and centuries, water vapor cycles quickly, yet it magnifies warming by trapping the Earth's outgoing heat and keeping temperatures stable. Without it, our planet would swing wildly between extremes of hot and cold. The balance of vapor in the air not only creates weather but also regulates climate on a global scale. A humid day feels different from a dry one not just because of comfort levels, but because of how water vapor interacts with the body and environment. High humidity slows the evaporation of sweat, making us feel hotter, while dry air speeds it up, cooling us more quickly. These subtle interactions remind us that water vapor is not abstract. It is something we feel with every breath and every step outdoors. Storms, too, owe their strength to water vapor. Hurricanes, for instance, are giant heat engines powered by the evaporation of warm ocean water. As moist air rises and condenses into clouds, it releases latent heat, fueling the storm further. This feedback loop is why hurricanes intensify over warm seas and weaken once they hit land, where the supply of vapor is cut off. Even thunderstorms follow the same rule. Rising air laden with vapor condenses, releases heat, and drives stronger updrafts, building towering clouds that can unleash torrents of rain and lightning. Every dramatic display of weather, from gentle showers to violent hurricanes, can be traced back to the invisible presence of water vapor and its constant cycle through the atmosphere. What makes this even more profound is the connection it creates between every part of our planet. The water vapor rising from a tropical rainforest might eventually fall as rain in a distant desert. The snowpack on a mountain, formed from vapor condensed into flakes, may melt and feed rivers that nourish entire cities downstream. In this sense, water vapor is a messenger, carrying the story of one place to another, binding the earth into a single interconnected system. When you watch the clouds drift across the sky, you are witnessing not just shapes of beauty, but the living breath of the planet, written in vapor, droplets, and endless cycles of transformation. Extreme weather phenomena may appear as chaotic, unpredictable outbursts of nature, but at their core, they are the result of precise physical processes fueled by energy moving through the atmosphere. Thunderstorms, hurricanes, and tornadoes all demonstrate how the atmosphere responds when energy imbalances become intense. A thunderstorm begins when warm, moist air rises rapidly into the cooler layers above. As the vapor condenses into towering cumulonimbus clouds, it releases latent heat, which drives the air upward even faster, creating powerful updrafts. Lightning, thunder, heavy rain, and even hail are the dramatic outcomes of this energy release. What feels like a sudden flash in the sky is actually the atmosphere frantically trying to restore balance, with electrical charges separating within the storm cloud until the difference is too great to contain, resulting in a lightning strike that equalizes the field. Hurricanes take this principle to a much larger scale. They are vast heat engines powered by warm ocean waters, typically forming in tropical regions where surface temperatures are high. As water evaporates, moist air rises and condenses, releasing heat and fueling the system. With the Earth's rotation imparting spin, the storm organizes into a rotating giant with spiraling arms of rain and wind. The calm eye of the storm is deceiving, surrounded by the eye wall, which is the most violent region, where winds roar and rainfall can be torrential. What makes hurricanes so destructive is not just their wind speed, but the storm surges they create, walls of ocean water pushed inland by their immense force. Entire coastlines can be reshaped by a single hurricane, and the aftermath leaves behind both devastation and awe at the sheer power of natural forces. Tornadoes, though much smaller in scale, are equally terrifying demonstrations of atmospheric physics. They often emerge from supercell thunderstorms where conditions align perfectly. When warm, humid air near the surface meets cooler, drier air above, the instability creates strong updrafts. If there is also significant wind shear, meaning winds blowing at different speeds and directions at varying altitudes, the rising air begins to rotate. Under the right circumstances, this rotation tightens into a violently spinning funnel that extends to the ground. Tornadoes can rip through towns with wind speeds exceeding 200 miles per hour, capable of leveling buildings and uprooting everything in their path within seconds. Their unpredictability makes them especially dangerous, even as meteorologists improve forecasting models. While these events may seem like freak accidents of nature, they actually follow the same rules that govern everyday breezes or gentle rain. They are simply amplified versions of the same principles of rising air, condensation, energy release, and atmospheric imbalance. The only difference is scale and intensity. A light shower and a hurricane are part of the same continuum, with the latter representing the atmosphere's extreme effort to redistribute vast amounts of heat and moisture. Even droughts and heat waves, though less dramatic in appearance, are extreme weather events in their own right, shaped by prolonged atmospheric patterns that block rainfall or trap heat in one region for weeks or months. What is most striking is how these phenomena shape human perception and behavior. Communities living in hurricane zones adapt by building stronger structures, creating evacuation plans, and learning to read the skies. Those in tornado-prone regions develop early warning systems and shelters. Farmers rely on their understanding of storms and rainfall to decide when to plant or harvest. In each case, human life bends to the rhythm of extreme weather, not the other way around. These events remind us of our vulnerability and dependence on forces larger than ourselves. They also push science forward, as studying hurricanes, thunderstorms, and tornadoes provides deeper insight into the mechanics of the atmosphere. The next time lightning splits the sky or news reports track a storm spiraling over the ocean, it is worth remembering that these spectacles are not random at all. They are the inevitable outcome of the sun's energy, the Earth's rotation, the movement of air, and the behavior of water vapor. Extreme weather is nature's raw performance of physics on the grandest stage, showing us how powerful and delicate the balance of our atmosphere truly is. Weather has always been more than a natural backdrop to our lives. It has been a decisive force shaping human history, culture, and survival. Every civilization that has ever existed has been deeply influenced by the conditions of the atmosphere. A farmer's livelihood depends on timely rains, a traveler's journey relies on favorable winds, and entire populations have risen or fallen with the rhythm of droughts and floods. Weather is not simply something that happens outside. It is a constant, invisible partner in the story of humanity, guiding our choices and testing our resilience. Consider agriculture, the foundation of settled life. Crops thrive only when the weather provides the right balance of sunlight, warmth, and rain. A season of abundant rainfall can mean prosperity and growth, while a year of drought can mean hunger, migration, or even collapse. Ancient civilizations like the Egyptians aligned their calendars and rituals with the flooding of the Nile, knowing their survival depended on the predictability of those waters. In other parts of the world, the failure of monsoon rains led to famine, reminding people that weather is not always a gentle partner, but often a stern master. Even today, with all our technological progress, farmers check forecasts daily, their decisions tied to the shifting patterns of clouds and winds, showing how weather continues to govern the rhythms of food and life. Weather also shapes human emotion and mood in subtle but profound ways. A bright, sunny day can uplift spirits, encourage activity, and foster optimism, while gloomy skies and long winters often bring feelings of fatigue or sadness. This connection is not imaginary, it has biological roots. Sunlight regulates our body's production of serotonin and melatonin, chemicals that influence sleep, mood, and energy. The lack of sunlight in certain regions during winter months can lead to seasonal affective disorder, a condition where depression is linked directly to weather and light. In this way, the atmosphere touches not only our environment but the inner world of our minds, shaping how we feel, how we work, and how we connect with others. Throughout history, weather has determined the outcomes of great events. Battles have been won or lost not because of strategy alone, but because of storms, fog, or sudden temperature drops. In 1812, Napoleon's invasion of Russia was crushed not only by the resistance of the people, but by the brutal winter that decimated his army. In World War II, the D-Day invasion was carefully timed based on weather forecasts, with tides, winds, and cloud cover deciding the moment that changed the course of history. These examples remind us that even the most powerful human endeavors are subject to the atmosphere's mood, and weather can alter the fate of nations. Migration, too, has been shaped by weather. Communities move toward fertile valleys, away from deserts, or along coastlines where the climate is gentler. Harsh weather conditions have forced people to adapt their homes, clothing, and lifestyles. The Inuit of the Arctic, for example, developed unique technologies to survive extreme cold, while desert cultures learned to conserve water and shield themselves from relentless heat. Weather has been the invisible hand sculpting culture, architecture, and ways of living across the globe. On a personal scale, weather shapes the everyday choices we make. We decide what to wear, when to travel, or how to spend time outdoors based on forecasts. A sudden storm can change a family picnic into an evening indoors, while a stretch of pleasant days invites festivals and celebrations. Even urban life bends to weather as cities prepare for floods with drainage systems, design buildings to withstand winds, or adjust energy consumption depending on seasonal temperatures. Perhaps the most striking thing is how weather connects all people. A thunderstorm in one part of the world may delay flights across continents. A drought in one region may raise food prices globally, and a hurricane may spark international aid and solidarity. In this sense, weather reminds us of our shared vulnerability, binding humanity under the same sky. It shapes not only our environment but our stories, our decisions, and the very way we understand our place on Earth. Every gust of wind, every raindrop, and every shift in temperature is part of a larger narrative in which weather is both a constant companion and a powerful force guiding human destiny. Weather is not just a backdrop to our lives. It is the living system of our planet, an ever-shifting balance of energy, air, and water. From the sun's uneven heating to the silent work of water vapor, from the fury of hurricanes and tornadoes to the quiet influence on our moods and history, weather shapes us in ways both grand and intimate. It feeds our crops, directs our journeys, and reminds us of nature's immense power. To understand weather is to understand not only the science of the sky, but also the story of life on Earth. The next time you look up at the clouds or feel the wind on your face, remember, you are witnessing the heartbeat of the planet, the rhythm that connects all living things under one shared sky.